Okay, well now I'm going to try to draw f from f prime. Starts out the same way. Now here, to get f from f prime, we have to actually do an integration. You don't really have to worry about it. It's just a way to get an answer from Desmos. You just turn it on. So again, I look at this and this is f prime now. So I might kind of come in a little way and notice that, you know, there's a critical number. There's a critical number for f. There's a critical number. So I have those three critical numbers. So my derivative is 0 there. So the function will be flat. Now here it's the derivative is negative and then positive. And so negative means it's coming down, and then positive. So here we have a relative minimum. Next we have a relative maximum, and right close to it then another relative minimum. And so, you know, as I look at these, okay, that's going to be a relative minimum. So I'm going to take, you know, one of my pieces here and bring it down to about there and call that the minimum. Maybe take this piece here and put it up there, call it the maximum. And then we have real close to it another minimum. Derivative is negative for just a short moment here. And then the derivative is positive again, so it grows. And I might kind of scoot out here so I can get these this down here. And so there's our maximum, there's our minimum. So it's just got that little hiccup in there, and then everything else should go this way somehow or other. And these were all negative numbers and getting steeper, so this thing should head down kind of like that. Okay, so I think the function itself should kind of come up. Let's see, wait a minute. I think I messed something up here because there's a critical number. Oh, so that was a relative minimum. Oh yeah, these are negative slopes. The value is negative, so I need this. And there we go. And so I do that. There's my minimum, comes up to a maximum, then a minimum, and heads up again. So now I'll turn this on, and you know, there's almost no difference in there between that maximum and minimum. But otherwise, yeah, I think I kind of got it right here. Mine should have been a little flatter, but there we go. I think I did all right. Now, so if you're going to do this, you might, you know, I had something as a default here that's pretty rough, really. So suppose I just do like 3x plus 2. You know, if I go with something like that, again, now I can see there's a critical number. All these values are negative, all those are positive, so the function comes down and then goes back up. And so I can kind of fix that up pretty quickly here. I'll make that my minimum. And these just kind of head up like this. And those head up like that. There we go. And so there I've drawn my function. Again, there's where my critical number is, that x value. And yeah, I could probably get it over just a little bit. And then and the derivative is all negative on the left side of that critical number. These are all negative values. The derivative here has all positive values, so the slope's going up. And actually it should probably get steeper and steeper, so I didn't draw it great. You know, I can bring it over like this to make it get steeper and steeper. There, that starts looking a little better. And I click that, and sure enough, that's what it looks like. Now, I will say that just to help you out with drawing, this particular function will always go through the 0.00. So, you know, I could have put all these down lower, and I would have been, well, I need to move it over a little bit, and this would have been a perfectly good answer. You know, so if your answer is just above or below the answer that you see on Desmos, that's not a big deal. But I will say the answer you get when you click here is always going to possess the 0.00. Okay, it's just the way I made it, and it helps it show up on the graph a little better so you can see it. Okay, so there's a couple of examples of using this particular application to get some interactive practice. So there we go.